Hello, and welcome back to Tlhalosement. This is your girl, Mamadi Mamarupi. And yeah, welcome to our first lesson of functions, and we're gonna start explaining why do we really need to do functions. Because I don't know about you guys, but when I was in high school, I sort of wanted to understand why do we really need to do certain things. So it was my way of finding interest into doing something, because if I didn't see the reason why I should do it, I would most likely not enjoy that subject because I didn't see why I should do it. So with functions, why do we really need functions? The first thing is that we want to mathematically express ourselves. So why can't we just talk or express ourselves anyhow and not use functions? The importance of knowing how to express ourselves with functions is that we can be able to build programs and do modeling with those programs. So the way in which computer grabs information is different from the way we grab it and express it ourselves. So we have to be able to put and describe everything around us in a way that a computer can understand it. And one thing that I'm teaching you today is that biology, they told you a cell is a basic unit of life, but here in the programming space, a function is a basic unit of a program. So you have to be able to understand the functions so that you can build a program. So why do we need these programs? Why would we want to use programs? So we are currently in the middle of the digital transformation, which means everything is just going digital. Like right now, you are now at home, you're supposed to be at school, but you're not, and you're schooling online, which means you're using programs to actually learn, right? So for me to be able to be teaching you like this, that means programs are at work. Yeah, so we need programs for that, and then we also need programs for doing animation to entertain ourselves, or graphically express certain things. So I wanted to show you the most basic animation of a program that is made out of small units of functions, but I failed. So it's called the flip book. So the flip book is it's actually images of one thing, one item expressed in different ways, and then when you flip it like this, mine is not flipping like the way it's supposed to. When you flip it like this, it's supposed to show images, repeat images of the same thing, and then it gives you the illusion of you thinking that thing is moving because you drew it in different shapes. Now it starts moving. So I'll make a separate video where I will just get somebody's flip book video on the internet and explain this concept very well. So we also need these functions for robotics. So robotics is the use of drones. I'm sure that's the one that is like most popular. We've seen people using drones to take what do you call them, for the aerial photographs of events and landscapes. So they use drones, and then we also use prediction models. We use programming for prediction models, like what is happening right now in the whole world. Let me just say, so we have coronavirus, and for us to be in the lockdown right now is because people sat down and they said, guys, looking at the way things are progressing right now, we will hit this much amount of cases, and because we will be having this much amount of people sick in the hospital, it's going to have this much impact in our health system, and when that happens, the health system will collapse, everyone will be infected, we will lose lives and all those. That was because somebody sat down and analyzed the data that we have. What is data? Mathematical expression of a phenomena, right? So somebody took that mathematical expression of that event, this thing that is happening now, and analyzed it and made a prediction of what will happen if things progress in this way or worse. And by looking at the way things are, it's only gonna get worse. So we're like, let's sit down, guys, which is why it's important for you to stay home and learn. So let's sit down, let's stay home and learn, and not be on the streets, okay? So it's important to do that. So mathematical expression is very important because you can actually use it to express anything, because like the world doesn't only revolve around coronavirus, at least for now. Yes, that's the correct statement. Yes, it revolves around coronavirus, but other than that, the world revolves around many things, right? So you can actually express whatever you want to express. So you should be able to, the first thing, I was looking at your CAPS document, the first thing that you should be able to do is to draw simple functions depending on whatever you want to express. So you should know about the input and output value. You should know those things. So those are the things that you should actually look into your textbook, so that you're able to understand the basic functions. But for now, actually, let me show you an example of how you can actually do that, how you can express anything, whatever you want, in form of a function. And then I will go into this section of the board. You don't need to see me for now. So let's say you have, let me check if I'm recording. Yeah, I'm on. So let's say you want to express your family in a form of a function. So we are expressing a family, right? So now we have to actually denote certain characters so that we know what they mean, because you have to be able to understand your program. That's what I'm saying. So we're gonna say family let, we are denoting in terms of characters. Let family is equals to F. And in a family, what are the characteristics of a family? You have parents, which is mom and dad, right? So we're gonna say parent is equals to P. And what do you have also in this family? You have kids. You have kids, which we can say it's K. So looking at this, if I were to say, just write me a formula, a function that actually describes a family. What is a family? So now I will say family F is equals to parents plus kids. So you see that I was just explaining the family, characterizing the family, and now I'm expressing it in terms of a function to say, for me to have a family, I must have parents and kids. So now that is like the basic way of denoting a function. But then if I want to go deeper, if I want to go deeper and explain this family, because we have different types of families, right? So in our families, we have families where there is a single parent with kids, only mom, or other families it's only dad with kids. Other families it's both parents and kids. So I want to explain your real family as to how does it go. So this is like the basic structure of family, parents and kids. But now I want to characterize it further. So in this other family, there is mom, there is dad, and they have 2 kids. Let me say 3 kids. And they have 3 kids, right? So we are sure that there is 2 parents, parent number 1, parent number 2, and there are 3 kids. So for this family, it's safe to say that family is equals to 2 parents plus 3 kids for this family alone. You understand? So if I want to explain another family where there is only mom with 2 kids, now the family will be, family is equals to one mom, one parent, because it's only mom, right? One parent plus 2 kids. So I have expressed this family, but you know, I know, like, you guys are grade 10, 11 and 12, so this coefficient is not really important because it's 1, the coefficient of any variable. If it's 1, then you don't need to show it off, right? Yeah, that is that. In other families, you will have families where there is, let me remove this. Oh, that's a complex one. Let's say you have mom plus dad. Oh, let me not do that one. It's too complex. Where there is like extended families with your grandkids, your cousins and stuff. It's just gonna take time. So what I'm trying to say is that you can actually express a family in terms of, like, you can mathematically express any situation you want so that a computer can be able to grab that information, right? So after that, knowing how to actually express this, I want us to look into these expressions, and keep in mind what we spoke about. We spoke about the family where there are 2 parents, and we spoke about a family where there is 1 parent, right? And then you could see the difference in the families themselves depending on how many people are present in a family. So these functions are the functions that, oh, my knees, damn. So these functions are the functions that you actually taught in high school. So you have your linear function, parabola, hyperbola, and exponential function. So these functions are the main 4 functions you'll be taught. I want you to see something common among these functions. There is this q, which is common among the functions, and there is this x plus p. X plus p says something about the functions, which is quite common, but does not mean that it's the same thing among the functions. Like we said, like we spoke about the families. All families have parents and all families have kids, but it doesn't mean that the parents are married, or the parents are, it's mom and dad, or whatever, because other families can be mom, aunt and uncle. They are still parents, or like parent, they are elders. Let me just say they are still elders, and they can be grouped in the same category, but doesn't mean that they are the same thing. So the same thing happens here. You will see the x plus p among the functions, but it doesn't mean that the function denotes the same thing when it comes to those. Doesn't mean that the expression denotes the same thing when it comes to those functions, but there is something in common about them. So like our so in a Cartesian plane, this will be your origin, right? And this is your y-axis, and this is your x-axis. So in a Cartesian plane, you will notice that your functions tend to move around. Why do we really want these functions to move? We need motion. We need to see images. Imagine if you were watching Isibaya or Uzalo and everyone is just stand still doing nothing. Then there will be no story. So for a story to be told, there should be movement. So these functions should move. Like I was saying, even with this flip book that didn't want to flip, for this ball to start bouncing that I drew that is not bouncing, for it to start moving, I should do something. There should be movement for me to start seeing this ball doing something, which means there is displacement. So this is what is denoted by this x plus p. This x plus p talks about the movement of the function along the x-axis. So let's say we have this dot over here, which can be defined as a function. And this dot, all of a sudden, because we want it to move, there's this boy who's throwing it across. So this is a boy here. This boy is throwing this dot, and we find this dot here. Maybe he's not throwing it, he's just pushing it, and we find it here. And we want to describe it again here, because we have its mathematical expression here. Now we want to also have its mathematical expression while it's here. But now there's a difference in position now along the x-axis. It's not in the same position where it was as it is here. So there is this distance that we want to explain, to account for. This distance is p. So we say we had our x here, which is here, but now we have it, this is x1, x2. We have it here. The distance between x1 and x2 is p. So if we want to talk about x2, x2 is equals to x1 plus p. So this is it. This x plus p, which you see are across the functions to be common. So all these functions can be moved along the x-axis. That's what this p denotes. So this one is different depending on the function itself. So if we talk about the parabola, parabola is like this. It's a cup. I call it the cup. It can either be facing up or facing down. We'll talk about this when we actually explain A. So this one is this point over here. It can describe that point, the turning point, depending on which graph. But when it's here, it's different, because this function is not a parabola. It's a hyperbola now. And this hyperbola is like this. It has vertical and horizontal asymptotes. So this actually can tell you something about the vertical asymptote, and this can tell you something about the horizontal asymptote. So these parameters, they tell you something different depending on the function itself. The same thing applies here at the exponential graph. So we will look into these parameters one by one, function by function, as to what do they mean. I had to make this point here because this other time when I was still a teacher, the question came onto the exam and it was about a hyperbola, and the student said it's a turning point, and that was a hyperbola, and I had to mark that. I called the student and I asked them why. It's like, but ma'am, you said P is for, I meant to say Q is for turning point. And I'm like, no, yes, for a parabola, yes, but not for a hyperbola. For a hyperbola, it tells something different. For a parabola, it tells something different. So I want you to be able to see these things and see what they tell you, the story they tell you, depending on the function itself, okay? So don't mix up the functions. Don't mix up the functions and the parameters so that you understand. I don't want you to cram. I want you to understand these things, okay? And Balandi Bukatalona, they can tell you even more. I'm just here trying to explain and make you grasp the concept better. On this video, please comment, ask questions, and let's keep busy, okay? Let's not be bored at home and do nothing, wasting our time, because we will end up losing this year if we are out there on the streets instead of being in the house learning. So we don't want to lose this year, okay? So ask questions. I'm just teaching you what I think I can teach you, but you asking questions will help me help you, because I'm just trying to help you. I don't know what you need. You tell me what you need, okay? So good luck and look out for the next video where we will be discussing the parabola and the straight line. We'll just go deeper. Go deeper. Okay, that's it for now. Bye bye. Follow Tlhalosement on Facebook, follow Tlhalosement on Twitter and Instagram. It's at Tlhalosement in all platforms. Bye bye. Ciao. Ciao, ciao, ciao. Mwah.